Chapter 3. Cement. Section 3.2 Portland Cement Production and Composition of Portland Cement. Hydration, setting and hardening of Portland cement. Technical properties of Portland cement. Corrosion and prevention of hardened cement. Characteristics and application of Portland cement. 3.2.2 Hydration, setting and hardening of Portland cement. Mechanism. Ways to avoid flash set. Mechanism of modifying setting time by gypsum. Not much gypsum. Hydrate formed by clinker hydration. Hydration mechanism. When mixed with water, Portland cement hydrates and forms heat. 3 carmidlyl.CO2 plus H2O carmidlyl.2 CO2 midlyl.3 H2O plus C.A. O2. Trialcium silicate hydrates rapidly and forms earlier strength and earlier heat of hydration. Tricalcium silicate is formed in a kiln when the charge contains an abundance of lime, and hence the greater amount of Ca in the reaction. Hydration mechanism. 2 carmidlyl.CO2 plus H2O 3 carmidlyl.2 CO2 midlyl.3 H2O plus C.A. O2. Dicalcium silicate hydrates slowly and is responsible for strength increase in concrete at later ages. The heat of hydration is liberated slowly. More dicalcium silicate is formed when the raw materials contain less lime. 3 carmidlyl.Al2O3 plus H2O3 carmidlyl.Al2O3 midlyl.6 H2O. Hydration mechanism. Tricalcium aluminate hydrates rapidly and liberates a large amount of heat. If this reaction were not controlled, concrete would set so rapidly, flash set, that it could not be used in modern construction. 3 carmidlyl.Al2O3 plus H2O3 carmidlyl.Al2O3 midlyl.6 H2O. Hydration mechanism. 4 carmidlyl.Al2O3 midlyl.Fe2O3 plus H2O3 carmidlyl.Al2O3 midlyl.6 H2O plus carmidlyl.Fe2O3 midlyl.H2O. The addition of iron or iron ore to the raw materials lowers the percentage of tricalcium aluminate. The iron reacts with the tricalcium aluminate, forming the tetracalcium aluminoferrite. This compound does not add significantly to the properties of concrete, but does cause the charge in the cement kiln to liquefy at lower temperature, lowers the point of fusion, thus reducing the energy required in cement manufacture. Ways to avoid flash set. A small amount of gypsum, CaSO4 midlyl.2 H2O. Intergrounding with the cement clinker retards the hydration reaction of tricalcium aluminate so that the calcium silicates can set firstly. Mechanism of modifying setting time by gypsum. The protecting layer is formed by wrapping up the clinker by calcium sulfoaluminate hydrate needle crystal, hinders the entry of water, slows down hydration and stops flash setting. Thus the gypsum can modify the setting time. 3 carmidlyl.Al2O3 midlyl.6 H2O plus H2O plus CaSO4 midlyl.2 H2O. 3 carmidlyl.Al2O3 midlyl.3 CaSO4 midlyl.31 H2O. Ettringite. Not too much of gypsum hardened cement corrosion. After hydration, tricalcium aluminate will react principally with sodium and magnesium sulfate, found in soil and water, which causes the concrete to disintegrate. Moderate sulfate-resisting cement limits the percentage of tricalcium aluminate to 8%. This compound is limited to 5% in sulfate-resisting cement. Hydrate formed by clinker hydration. In full hydration, hydrate produced by clinker hydration is as following. Calcium silicate hydrate gel 70%, calcium hydroxide 20%, calcium aluminate hydrate, calcium ferrite hydrate. Atringite. Fig. 3.2.2 Degree of hydration. Hydration, setting, and hardening of Portland cement. Setting and hardening. Definition. Process of setting and hardening. Factors influencing setting and hardening of Portland cement. Definition: setting process, hardening process. The process of losing plasticity and becoming dense of the paste, which is formed by mixing the cement and water. Hardening process. The process of forming hardening cement paste by the paste, which loses plasticity and its strength increases with time. Process of setting and hardening. Initial period. Initial dissolving and hydration, mobile and plastic, lasting for 5 to 10 minutes. Incubation period. The performance of gel layer surrounding cement is excellent. Particle growth lasts for 1 hour. The cement particle expands, bonds and hydrates after the cracking gel layer, lasts for 6 hours. Porous spatial net coagulation structure, losing plasticity. Setting period. Fillings of gel to capillaries, lasting for 6 hours to several years. Hardening period. Process of setting and hardening,